So, next up, we're very lucky to have Lloyd McKenzie with us, who Sheridan spoke about a few times during her presentation, just FYI, Lloyd. And Lloyd is going to talk to us about FHIR questionnaires and maps. So, just a brief introduction to Lloyd. Lloyd is a globally recognized expert in the HL7 standards community, and he's one of the three initial editors of FHIR. He is a co-chair of the FHIR Infrastructure Working Group, a member of the HL7 TSC, the Technical Steering Committee, and an HL7 Fellow. And Lloyd also leads on both the ONC and International FHIR SDC projects, which is the Structured Data Capture projects. So Lloyd is a wealth of knowledge about FHIR, and we really appreciate him being here. So thank you very much, Lloyd. I will pass the floor over to you. You should have the green share button.
Excellent. Before I do that, I just wanted to comment on the question about what qualifications do you need to have to be a participant in a working group, and basically a willingness to show up. The community is incredibly welcoming, and if you're willing to show up and participate, they will welcome you with open arms. You do not need to be an expert. You need to be willing to listen. But yeah, I got hooked on HL7 over 20 years ago. And I have changed where I work based on companies' ability to support me in my HL7 habit and engaging with the standards community. It is a really great group of people. And so do not in any way be afraid to show up. And there are lots of work groups. So find one that matches your interests, fits your personality, and dive in. All right, I'm going to talk to you about questionnaires and maps, not the how to get from Victoria to somewhere else, but the ability to map data structures. And there's actually a fair bit of overlap, well, some degree of overlap between those two topics. This set of presentation materials is licensed under Creative Commons. So you are free to use the PowerPoints if you want them. Linda has them. She is free to share them. You don't have to just stick with the PDF. And there's lots of other free content available on HL7's GitHub site. So you're really benefiting just from my voice, but the slides themselves are freely available. All that we ask that you do is give credit to the people who wrote them, which in this case is Brian Postlethwaite and me. So I am sure that all of you at one point or other have had the pleasure of encountering forms in healthcare, whether it's an admission form or an insurance form, or if you work in healthcare, there is paperwork galore, file cabinets, or if you're lucky, maybe electronic forms to capture pretty much any kind of information that you can imagine. And there's a good reason for that. If you think about FHIR, FHIR now has a little over 150 different resources. So there's different resources for procedures and vital signs and patient demographics and family history and all those sorts of things. And each of them are their own slightly complex data model that reflects what is the set of information you need to capture when you're talking about these things. And there's also the questionnaire response resource, which you can use to ask questions about your allergies and your healthcare conditions, and when did you last see your GP, and how tall are you, and pretty much anything you can imagine. In fact, absolutely anything you can imagine, you can ask with a questionnaire response. And that's a whole lot easier for a lot of systems to wrap their heads around. It's a lot less work, and you can have a relatively simple client piece of software that can handle any kind of data that you might want to capture. And you can change the type of data that you want to capture on a whim, and the system just handles it because it knows how to look at a questionnaire and say, oh, that's a question. I should display that text on the screen. And oh, that's the type of answer. I will use this control to prompt the user for an answer, and just keep doing that over and over until it gets to the end of the list. Very straightforward thing to do. We use control forms or questionnaires for a number of reasons, particularly in research, but also in other places. It matters how do you ask the question, because if you have 5 or 10 different EHRs and they present the way to capture the information in a different manner, prompt with different text, expose choices for answers in different ways, or maybe even expose completely different choices for answers, period, you're going to get different data, even if the users happen to be the same, because we know from research that the order in which you ask things, the way that you phrase things, the order in which you present possible answers, the types of answers that you present, whether it's pictures or checkboxes or drop downs, all of those things will influence what users choose. And in some cases, how things get displayed matters. You want to show a picture of the face or the body part and have somebody capture information that way, and that's hard to do with most EHR user interfaces. It also gives you complete freedom to capture exactly what you want in the way that you want. And of course, lots of people in the research space, but in other places as well, want to have that freedom to ask their questions in their way. Forms, however, are not only used for data capture. This is an example of a prenatal form, and there's a lot of stuff on this one piece of paper. And the power of having all of this stuff on this one piece of paper is if you have a clinician who is familiar with the piece of paper, they can take in a patient that they've never seen before, give this thing a quick scan and know exactly what's going on. Or if they have a question, their eyes will immediately zoom to that particular place on the form, and they've got their answer. And that's hugely powerful, and is the reason that we have such forms and why people just don't take longhand notes on white paper and stick that into their folders, because having a consistent presentation of information reduces cognitive load and speeds up data consumption and makes it more likely that key information will actually be seen and acted upon. So forms are awesome. And so the question then becomes, so why do we have 150 plus resources in FHIR? Why don't we just have questionnaire response? Because it can do absolutely everything, and it gives people the control that they want, and it makes displaying information consistent and beautiful. And the problem is, of course, that prenatal form that I just showed you is the prenatal form for a particular institution at a particular time. And every single institution that you go to, unless they've done some heavy work within their organization, is probably going to be a different form. And it's also quite likely that the form that they had 3 years ago is different than the forms that they have today. It's also not really straightforward to query against the form. If you have a collection of intake forms from 20 different hospitals, as well as various other completed questionnaires, and you say, please tell me this patient's allergies, you're probably not going to get a terribly useful response, because there's no standardization about how allergies are captured, where they're captured, what they look like, what information about them is recorded. Some cases it might be a simple checkbox with a heading that says allergies, and you've got penicillin, latex, and other top 10 ones that you happen to care about, and that's it. Other times it's a allergies, and you've got a text box where they can type whatever the heck they like. Or various other kinds of possibilities. Also, the meaning of elements can be dependent on where they appear. You may see the label, address, or name multiple places on the form, and it means different things in every single place. It might be the name of the patient, it might be the name of their next of kin, it might be the name of their GP, it might be the name of who knows what. And so trying to figure out what does information mean is very difficult. So great for capture, not so great for querying and discovery and consistency, particularly when it comes to things like decision support and analytics. And that's one of the main reasons why we want to have electronic data, is so that people can find the data that exists and compare the data that exists, and have the computer highlight things like, hey, this particular patient looks like they're at risk for X. Would you like to do Y as part of this visit to help mitigate that? You can only have that work if the software that's doing that decision support can find the data. So we have questionnaire responses that are awesome, but also kind of suck. And so how do we sort of manage that? And the answer is we use both, or at least we can use both. I mean, there are circumstances where you simply don't care about having tight control over data, or your user interface is fixed by the particular tool that you're using, and it's pretty static, and you don't have to worry about using questionnaires to define that. And your standardization comes from your fully baked and locked user interface. But in those circumstances where you do want to have dynamic data capture, where you can change the rules and change what you capture on a regular basis, but you also want to have consistency in the data, we can use forms or questionnaires to gather information. And in the happy case, we can use a technology called population, which says, hey, the first question on this form is, what is your given name? And the second question is, what is your last name? And guess what? I already know those things because I've asked you for them 20 times in the last year. And I could actually go and grab that information from the database and fill in the answers that you gave me the most recent time of those last 20. And if you happen to have changed your name because you've gotten married or gotten divorced, or just decided that you were tired of your name or whatever it is, then you can obviously change it. But 99.9% of the time when people see this form, the answer is the same as it was last time, because dates of birth and names and other genders and things like that don't change very often. Doesn't mean that they don't change. We need to allow for the possibility that they might, but having the data that was there from before is helpful. And then the user reviews the information, changes it when necessary, fills in the answers that aren't already there, like, why did you come in today? You probably don't want to grab that answer from a week ago because hopefully it's not the same. But lots of it you might be able to still populate. And then you can extract the information from the completed form. And you can take the why did I come in and put that into an observation or a condition. And you can take the fact that they've now changed their phone number and propagate that back into your patient registry. And that sort of gives you the best of both worlds. You've got the form that lets you ask whatever you like, but you can still expose that information in a standardized way that other systems can come and query easily and compare easily. And because we have this migration of data where we're capturing it in one place and then moving it into another place, ideally, we want to track how that happens so that if there's a glitch and people are extracting information from the wrong place or doing it inconsistently or something like that, we can trace back where the data came from and maybe fix it. And so FHIR also has a provenance resource that lets you tie together the, here's my data in the allergy intolerance or observation or procedure or some other resource, and this is the questionnaire response that it came from. And when you're passing the data around, sometimes you just pass around the allergy intolerances or observations or procedures. Sometimes you might also pass around the questionnaire response and the provenance that links them. It really depends on what the downstream system needs. Does it need to have access to source of truth, what the user originally put in, or is that sort of noise and overhead and they don't want it? It's up to you in the design of the system what you choose to pass along. So let's take a look at the FHIR questionnaire resource. And I mentioned that it was a pretty simple data model, and it is. There's a whole whack of metadata, like what is the title of the questionnaire and who created it and when was it released? And is it currently active? Or is it one that you're supposed to use? Or maybe it's draft, we're working on it, but you're not ready to use it yet. Or maybe it's retired and you certainly will have existing data that uses it, but you really shouldn't be capturing new versions of it. And there might be categorizers that says that, hey, this is an admission form, or this form is for pediatrics or oncology or whatever, so that when you have your virtual file folder of 1,500 forms, you can have a hope of actually going and finding the one that you need right now. So we've got that. And then we have a structure called item. And item is a recursive structure that contains the content of the questionnaire. So items can contain items, can contain items, can contain items, and you can nest as deeply as you like. FHIR doesn't have a limit. If you want to drill down 10,000 times, FHIR won't yell at you. You will probably find most user interfaces become pretty unusable if you nest that deeply. And in practice, we generally don't see more than 3 or 4 levels of nesting, maybe 5 if you've got some really complicated instruments. So what kinds of items can you have? We have groups, which are sort of organizers, a little heading in your questionnaire that says demographics or family history or past medical history or whatever. With groups, they have to have children, at least once you're finished designing the form. If you're sort of halfway and you haven't completed everything, it's okay if they don't, but once you're finished, you should never have an empty group. But you'll never actually capture an answer. So when you say demographics, you can't answer that with 5 or female or something like that. It's a heading. Then we have questions. I presume most of you know what questions are, because exams and stuff. By the way, if you wanted a fun exercise, you could take all of your exams and turn them into questionnaire resources. And we've actually got a change request out that somebody also wants a standard way of defining the answer key so that we can do automated evaluation of exams once they've been filled out. So FHIR gets used in strange places sometimes. So question gives you text and also says, and here's the kinds of answers that I want. Maybe it's a string, maybe it's a number, maybe I set some parameters like it's a number, but it has to be an integer, and it has to be between 1 and 10 or whatever your rules are, or maybe it's a code, and you have to pick one of these 15 diagnosis codes. Or maybe you're also allowed to pick other, in which case you can type whatever you like. And then we have display items. Display items are just text that appears on the screen, but they're not headings. So this might be help text, this might be instructions, this might be a copyright notice, this might be a blurb that says how awesome the organization that created the form is. Doesn't much matter. One other thing is that you can have questions inside of questions. So you can have a question that says, have you had any episodes like this in the past 6 months? And if you answer yes, then beneath that it says, please indicate approximate date, or something like that. So let's look at an example. And this is, of course, aimed at students and most of us like to eat pizza, and it's not healthcare-ish. So hopefully it's relatable regardless of what disciplines you're interested in. So what does this actually look like in FHIR? We can capture a prefix or a label for the question. You don't have to do this. If you don't do this, either you won't have any, or the form filling tool that displays the questionnaire to you will make something up. But sometimes you'll have a rule that says you need to fill in either question A or question B, and it's helpful if the display actually shows A and B as opposed to 1 and 2, and so we give you control over that. Then we have the text. So in a group, this would be your label. In a question, it is the question text, whatever is being displayed to the user. Here we have a child display item, and it implies some things about the parent question. Specifically, it says that this is a required question. You're not allowed to order a pizza without specifying at least one topping, at least from this particular restaurant. And it also says that this is a repeating question. You're allowed to have more than one ingredient on your pizza because we're not cruel. And then we have our list of options. And those can be defined directly inside the questionnaire, or they can be a reusable set that's derived from elsewhere. I suspect that you either have had or will have some training on terminology and code systems and value sets and stuff like that. So it really depends on how you want to maintain your questionnaire, what makes sense here. And then we actually have a nested question that only gets turned on if you choose other, where it says, please specify as your question text. And in this case, instead of the question type being for codes, where we have a code for cheese and ham and mushrooms and other, this case is just text where you can type anything. So if you have a particular hankering for anchovies or escargot or some other perhaps less common topping on your pizza, if you think there's a hope of you getting it, you can type whatever you like there. And that is the gist of how questionnaire works. So if we go look at the detailed model, and the nice thing about doing an online course is that you guys actually get to see the whole thing on a screen right in front of you, which means you might actually be able to read this, unlike when I do it on a projected screen where most people in the class can't. But if you remember that simple diagram of the metal model that I showed you, there was a bunch of metadata, and this is all metadata. So what is the title for this? What's the identifier for it? Is it experimental, which means this is a plaything that's not intended for real use? Subject type, what kinds of things can this questionnaire be about? It's about patients, or it's about providers, or it's about countertops. It could be a variety of things. When was it created? Who created it? How do I reach out to the system that created it? Because I think there's a problem. There's a spelling error on page 3. A more detailed description so that when you're searching through a list of questionnaires and you see a title and there's 15 things that all have the same title and you're going, which is the one that I want? Read through the description and hopefully the descriptions at least are different. What country or province or other region does it apply to? Legal stuff. And then we have items, where we have an ID, which will appear on both the questionnaire and on the response to sort of say, this is what I'm answering. We can point to standardized question definitions from elsewhere. We can point to terminologies like Lloyd or SNOMED to say, here's what this question actually means. We've got the text of the question. We've got what kind of answer do I want, or indicate that this is a group or this is a display item. We can cause things to be turned on or off based on certain rules. We can say this is a read-only answer. Maybe I'm going to calculate a score. So I'm going to gather APGAR, and I'm going to prompt you for the baby's color and breathing and things like that, and you'll score them numerically. And then I'm not actually going to let you type in the total APGAR score. I will calculate that for you, and so I don't actually let you change that. We have the ability to list answers. We have the ability to specify default values. So if you don't answer anything, this is what's going to get filled in for you. And that's the data model to be able to capture absolutely everything you can imagine in the healthcare world or outside the healthcare world. So what does that look like in practice? On the left-hand side, we have a questionnaire. So it's got an item, and beneath that item, we have some child items. The parent item is a group, and it's a repeating group. And then on the right-hand side, in the questionnaire response, we have an item, and you'll see that we have this G1 as our link ID. That's how we tie information in the questionnaire response to information in the questionnaire. And then we have our question number 1. And you'll see here, question 1 does not say that it repeats, but it's still showing up twice in the questionnaire response. And the reason that happens is because repeats is in the context of the parent. So within the group, you can only have one Q1, but you can have multiple groups, and we have multiple groups, and therefore Q1 ends up showing up more than once. So that's the foundation of questionnaires in forms. Let's dive into structured data capture. In FHIR, when we started out, we didn't really define it. We adopted it. We adopted a rule called the 80% rule. And we refined it and redefined it a little bit in terms of a particular context. But the gist of it is that we're only going to include content in the core specification if we think that most systems will use it. In the version 3 world, CDA, we tried to come up with a data model that would capture absolutely everything. So in address, we have the ability to do things like houseboat across the street from, which is an address part that matters in the Netherlands. And we have the ability to capture your address in kanji and various other characters, which matters if you're in Japan. But the reality is most systems in the world, when they deal with address, only deal with a couple of address lines: what's your city, what's your province or state, what's your country, what's your postal code, and call it good. And we learned from version 3 in CDA that when you throw everything into the specification, first of all, you fail because there's inevitably something that you didn't think of or something that comes along later. But also, it's a real pain to read, and it becomes really abstract and people implement it differently. So in FHIR, the resources only include those things that we think that most systems know how to handle when it comes to questionnaires. The problem is that there's a really long tail of functionality that is really important to certain subsets of healthcare clients, where they want to say, this needs to be green, or the question text actually needs to change on the fly, or I want that beautiful thing where the name automatically gets filled in with the information from the database. And we could not safely say that 80% of systems out there that use questionnaires are able to do all of those things, but we still wanted to define them. And so structured data capture is a FHIR implementation guide that tries to define not all of, but a lot of the major extra things that people want to do with questionnaires that didn't make the cut for the 80%. So you can think of it as it takes from what to 80% of system support down to maybe what to 20% of system support. There are still going to be some more weird and esoteric things that aren't in SDC, but there's a lot of stuff that's in SDC that lots of systems care about. And specifically, we talk about workflow. We talk about different ways of how to display forms, behavior in forms in terms of validation and rules, the ability to automatically fill forms in, the ability to automatically extract data from forms, the ability to have adaptive forms that aren't predefined, but change what questions you get asked based on what you previously answered. And actually, there's one more that's more recent that's not in this list that I forgot to add, which is componentized forms, where you have reusable chunks, where you have a data element library of questions that you can call upon and say, I want that question, that question, that question, that question, and just point to them and have all of the logic and rules and stuff maintained elsewhere for consistency. So let's drill into those a little bit. In terms of workflow, first thing is, what are the types of systems that are involved here? Can we standardize those so that when somebody goes to market and says, hey, I support questionnaires, that they can be a little bit more useful in stating what exactly is it that they do? Because there are a lot of different things that a system could do and still be honest when it says, I support questionnaires. So we have form fillers, which are the tools that display a blank questionnaire and let you answer questions and save it and then come back and continue and validate and make sure that you're actually following the rules. We have form managers, which is sort of the electronic file folder of all of the forms that exist that you can search and find things in, but may also have some additional functionality like holding all of the value sets that define the allowed answers for some of the forms. We have form response managers, which is where does the data get stored when you save that work in progress form? Because the form filler might just be something that runs in your web browser and you can't actually store anything. And it kind of sucks if you fill something out and then your laptop crashes and you don't want to start all over again. So it's nice to be able to save things, or maybe even copy from the one that you filled out last time and update it. Then we have form receivers, and those are a little bit different. With a form response manager, I can store something that is in progress. I can update it. I can look for things that already exist. A form receiver is, when you are complete, please submit your form here. And you get a little thank you, and your form disappears forever into a black box. And hopefully something actually happens with it. But there are lots of processes in healthcare where we stick a form into a black box and trust that magic will happen. And then form archiver is a little bit esoteric. It's the ability to store what has happened. It's also kind of a black box, but whereas the form receiver, you're hoping something's going to happen with the data. With the form archiver, it's essentially just auditing things and holding onto them forever, but you're not going to see it again unless there's litigation or something or other. So that's part of workflow, but workflow also includes I want to tell a patient to fill out a form. How do I do that? I want to submit a form. How do I do that? How do I know that a form has been filled out as I've asked? How do I retrieve the allowed values for this value set that says all SNOMED procedure codes of body, site, lung, when that set of codes changes once a month, and in fact changes depending on what country you happen to be in. And so FDC tries to answer all of these questions. In terms of complex rendering, maybe you want colors, maybe you want bold or italics, maybe you want to embed pictures, maybe you want to hide certain questions. So there's a score that we're calculating in terms of your risk for suicide or something like that, but we don't necessarily want to show you the score that we're calculating. And so it's behind the scenes, but still part of the stored data. Maybe you want to control how the answers get captured. Do I have a drop down? Do I have radio buttons? Do I have a grid? And if I do have a grid, what's in the X direction? What's in the Y direction? What are the headings? How wide are they? Maybe I'm going to prompt you for a phone number, and I want to tell you that I want dashes in my phone number, and here's the positions that I want them in, because I'm assuming a North American phone number. And be careful about what constraints you put in place, because the whole rule doesn't necessarily work the same way all the time. In terms of behavior, we might want to turn things on or off. So if your depression score is above this value, then we're going to ask some more follow-up questions, because we want to really understand what's going on. Whereas if you scored below that, then things are probably fine, and we don't need to prompt you for those extra questions. Or maybe we're only going to prompt you with certain possible answers based on the gender that you've filled in. That's also fraught, because gender isn't necessarily as clear unless you're really careful about how you ask for the data, and you trust people to give you an answer that will properly inform the answers that you're turning on or off. Sometimes you just want to have rules like you have to answer at least 2 of these. And that's not really a rule. It's inside a single question. It's across a bunch of questions. Sometimes you want to constrain the data that's being captured. So you want to prevent somebody from typing an essay in the "do you have any feedback" column, because you don't have time to read an essay. Thank you so much. Or maybe you want to constrain the range of dates, or you don't want them to fill in a whole date. You just want the year or year plus month. Or maybe you're doing attachments and you don't really want WordPerfect for files because you have no idea how to process those. And you also don't want the 2 terabyte radiology image from your PAC system. You want something slightly smaller so that your machine doesn't crash. Maybe you're constraining your units of measure. All of these kinds of things are possible. One of the cool things that FHIR brings to the table that was never possible with paper forms is the ability for answers to be pointers to data that lives elsewhere. So in the paper world, if you wanted to ask a question like, who is your primary care provider? You would have a question where you would specify their name and maybe their phone number. Or if you're doing it targeting healthcare providers, maybe you would get their license number. And then somebody would have to go figure out who the heck this person actually is in the system and look them up. With FHIR, you can actually have an electronic form that says, who is your primary care provider? And you get a little search screen where you can type in a name and you can see all of the Dr. John Smiths that exist, and you can find the one who works at 123 Newberry Road and say, that's my GP, which is awesome. But the core specification just lets you say, this question is of type reference. It doesn't let you say reference to what. So is it a practitioner, or is it a location, or is it a document reference? And it also doesn't let you say, and by the way, I don't just want any document reference, I want document references with codes that look like this. Or I want document references found on such and such a server, or patients found on such and such a server. It is even theoretically possible to go look for Dr. Smith and say, they don't appear to be in this registry. Let me click on this button and I will go add them. Probably not something that you want the patients to do, but may make sense in other circumstances, or may make sense in circumstances where you're looking for conditions or allergies or something like that, and creating a new one is less likely to cause a problem than putting a new record into a registry. So we have extensions that let you do all of these things. There's also extensions to do calculations. So you can, at the time that you're launching your web app or whatever it is to fill in your form, you can say, oh, and by the way, the patient that I'm currently looking at in the EHR is Jane Doe, and here's the information about their encounter, and here's the information about me. And all of that information can then be leveraged in the population process to go find patient Jane Doe's allergies and family history and whatever. And we can use a couple of different languages. CQL, FHIRpath is actually a subset of CQL, it's a simpler version. While it has FHIR in the name, it's not actually FHIR specific. It can navigate a wide variety of data models, but it lets you go and find stuff. You can query data, you can filter data, you can perform different expressions on the data to find what it is that you need. And we also have the ability to construct forms based on other forms. So lots of cool things that we can do in the questionnaire universe that hopefully makes the forms more useful and more efficient for the end users, and make sure that the data that is being captured follows the rules that we want and ensures data quality. Pre-population is another big thing. And pre-population is that ability to go look at what already exists in a database somewhere and fill in answers on the screen so that the user doesn't have to remember, that you're not trusting them to type things properly, because maybe they won't. Helps them to remember things. If you can sort of populate, these are the allergies that we already know about, you can look at that list and go, oh yeah, I would have forgotten to mention that one, but that's true. And it also means that you can go, oh yeah, no, we decided that I wasn't allergic to that. That was just gas, or whatever the circumstance happens to be. And so you can make the changes, and it's more informative than just if you list things. Because if you forget to list something, that doesn't say as much as I gave you this list of things and you removed some of them. That tells me more about what I should do with my backend data. So how do we make this work? We need three things plus knowledge. So first is we need to have a place where we can go and get the data from. So you have to have a server that exposes data over FHIR. I cannot go and retrieve your name and phone number and date of birth unless there's a server that I can query that stores that information and provides it to me in a standardized way. The very first version of FTC actually tried to get data out of CDAs, but implementers found that that wasn't terribly successful, and very few people were interested in even trying. So the current version of FTC only lets you retrieve data from FHIR. So you need to have a FHIR endpoint that will source up patient data or allergy data or family history data or observation data or whatever it is that you're looking for. Then you need to be able to map from the data that you get over that FHIR interface to the specific set of questions that you have. Because maybe you have a single string field for name, whereas FHIR has a field for prefix and one for suffix and one for family name and a repeating one for given name. And so you might need to concatenate those things in a particular order in order to populate that string. And so you'll have to do that mapping. Then you need to have an engine that can actually execute the mapping. So given that standardized mapping that's found in the questionnaire, I can make that, go retrieve that data, do the transformation and fill in the answers. And then you actually also need to have somebody who understands what the data is going to look like. So FHIR will tell you this is what an allergy intolerance can be, but the core specification is not going to tell you what codes are going to be present in allergy intolerance, and isn't going to tell you how likely it is that they will capture the reaction for the allergy, because that's optional. In fact, most things in most resources are optional. And so you probably want a profile like Canada Core, Canada Baseline, or US Core, or something like that to leverage to give you a greater sense of what data is likely to be present. We define three different ways of doing population in SDC, not because we like making things complicated. The universe just makes things complicated. We just reflect that reality. The three are observation-based, FHIR path-based, and structure map-based. Observation-based is the simplest. It basically means in your questionnaire, you go and put typically a LOINC code in most of the world on each question that says, hey, this is weight, or hey, this is height, or hey, this is age, because there are LOINC codes for most kinds of questions that you might want to ask. And we do that even when we're not trying to populate forms, to just capture what are the semantics that we're trying to represent here, so that somebody else looking at our questionnaire data has an idea of what it is. There's one other thing that we need though, which is if I say, I would like to gather the existing weight for this patient, we need to know how far back do you want to go. If I have a weight for this patient from 20 years ago, that's probably not super useful, especially if the patient currently is 21 years old. Not going to correlate terribly well with what their weight is now. On the other hand, if I'm looking at a 50-year-old and I have their height from 20 years ago, that's probably just fine. And so we specify what is the date boundary in terms of how old do we look when we're trying to find that information. And so if you look at this, we've got a questionnaire item. It has an extension on it. Hopefully you've heard about extensions, that they're the ability to plug extra stuff into any FHIR data model. And this particular extension says, I'm interested in weights, or I'm interested in data that is no older than 3 months. And then we've got 3 different codes. So we've got the LOINC code for body weight, we've got the LOINC code for measured body weight, and we've got the LOINC code for dry body weight measured. And there's a bunch of other LOINC codes that also deal with weight, but we decided we don't care about those. And what that will turn into when we're doing the population is it will generate a query and say, against whatever server I'm grabbing data from, I want to find all the observations where the subject is whoever the current patient is for this questionnaire response, and the code is LOINC for body weight, or measured body weight, or dry body weight, and it's completed because I don't want entered in error or other funky things. And assuming that we're doing this many years ago, this would be the date that's 3 months ago from today. And we're going to sort by descending date, and we're only going to bring back the first one because we don't care about all of your body weights before that. We just want the most recent. And that will give us an answer that we can plop into that question. And basically, when the user's going through, it says, what is your current body weight? And we fill in the weight that they were 3 months ago. And they have the option of saying, yeah, that's pretty much the same, I'm stable. Or they can say, no, I've lost 10 pounds since then. Or they can go, yeah, that's not quite accurate anymore, so let me change that. And some of the cases, at least, you'll have saved some time. The problem with observation-based is, of course, that it only grabs stuff that's stored in observation. And the most common things that you want to pre-populate are, what is your name? What is your gender? What is your date of birth? What is your current phone number? And none of those are typically stored in FHIR as observations. And so for these, we need to be a little bit fancier. And so we have an ability in Questionnaire to put in more extensions where we can actually fill in a path that says, I'm interested in this patient resource. And this particular element I'm going to grab from patient.given first repetition. And this element I'm going to grab from patient.family name. And this element I'm going to grab from patient.birth date, and go through and say where all of your data comes from. And with something like this, you can also have a section that repeats and say, this group that talks about family history, we're going to create a new one of these for every single family member history we've got for the patient. And then within that family, we're going to have who is the relative's name and what's their relationship. And then we'll have another repeating structure inside that that says, and what conditions do they have, and when was the onset, and all of that kind of stuff, depending on how much detail you want to capture. So much more flexible, much more powerful. The downside of this, of course, is that you have to actually write FHIR path. So it's not just go look up a Lloyd code and fill it in. It's figure out where does that data live in FHIR and write the path to make that happen and write the queries to make that happen. There is a third option, which is structure map, which is super sophisticated. You can transmogrify data in all kinds of weird, wild ways. You can transform vocabularies. You can have if, then, else logic. But it's much more complex to write. And because it transforms all of your source data into all of your questionnaire response data at once, it's also not dynamic. FHIR path-based, you can actually go and grab data based on previously answered questions. Structure map, you can't. On the other side, we have extraction, which is taking information already inside the questionnaire response and creating other resources. So creating observations or allergy intolerance records or updating the patient resource. And again, there's 3 different mechanisms for doing that. Similar to, but not exactly the same as our extraction mechanisms. We do have tools for doing all of this stuff. So I've shown you some raw XML. The reality is that most people these days, if they're looking at anything raw, it's probably JSON rather than XML, but XML is my happy place. So that's what I typically document in my examples. But most people do not like handwriting JSON or XML for some reason. There are lots of tools where you can drag and drop. There's a tool from the National Library of Medicine that has available to it all of the link codes in existence, and you can just pick link codes and it'll automatically create your questionnaire for you. And there continue to be new tools that come on the market. Some of them you have to pay for, a lot of them are free, some of them are open source. And not all of them support everything that's in SDC. In fact, none of them support everything that's in SDC because SDC has a lot of stuff, but they're all getting better and getting more and more capable. I also wanted to talk about adaptive forms. So in this sort of typical space in the form world, you define all of your questions in advance. So I want to know the patient's first name and last name and gender and date of birth, and I'm interested in their allergies, and I'm interested in their major medical conditions, and you list all of the things that you want to know. But there are some instruments, things like Promise, where you don't get to see the list of questions in advance. Instead, you just get the first question and you provide an answer. And that goes back to the magic engine. And it then says, okay, and here's your next question. And you answer that. And then you get another question. And it sort of looks like this. So you start out with an empty questionnaire response and a question that says, what's your name? And so you fill in your name. And it comes back and says, cool. And what is your quest? And you answer that. And it says, great. And I gave this course probably 8 years ago. And Dan Freeman, who was one of the main leads in Lloyd, shared with me that Lloyd does indeed have a lot of questions predefined in it. And there are Easter eggs in many places in healthcare, and this is one of them. So it gives you an alternate way of managing questionnaires. And a few benefits of that. One is You might have a library of 1,000 questions that you're pulling from, and you probably don't want to, and for that matter, the poor little web form probably doesn't want to load all of those into memory. Or you might think that your list of questions is proprietary and you don't want to show people what your secret sauce is in terms of what all of your questions are and what your logic is to answer them. Or maybe your back end is this fancy AI thing that makes up questions on the fly and you don't actually have a list and specific logic. You've got this magic system that just decides based on data that exists in your database, based on answers already given, based on stuff that's queried from elsewhere, and a whole lot of AI magic decides what questions are going to be asked and in what order. And so you can still use the questionnaire resource to do that. So that's all I wanted to say about questionnaires and forms. And then I was going to jump into mapping. And then I was going to let you guys ask questions that you have. And if you don't have enough, then I'm going to subject you to a walkthrough of some of the specifications. So start thinking of your questions now, because walking through specifications is boring. So let's talk about mappings. In FHIR, there's really 3 different tools to support mapping in the healthcare space. We can embed mappings in profiles. We've got a resource called Concept Map, and we have a resource called Structure Map. Mappings are really important when it comes to healthcare data exchange, because the reality is that we don't have one world government that dictates that we do things the same way in all countries, in all provinces, in all hospitals, in all clinics, for people and kitty cats and cows. And if we did have such one world government, we would probably collapse, because the reality is it doesn't work to try to do everything the same way. And so there are lots of data structures out there in terms of internal databases, in terms of questionnaires, in terms of other standards. And we want to be able to take data that is expressed in those other forms and convert it into our form, or we want to take the data that exists in whatever our preferred form is and turn it into something else that other people can use. And so by long history, data mapping has typically been done with Excel spreadsheets, where you create your list of here's all the data elements that I've got, and then create columns that say, and here's where it goes to in system downstream, and throw in comments and other kinds of things, and maybe references to terminology maps or whatever is necessary to express that. And it works. I mean, Excel is used quite a lot because it is often good enough for purpose. But Excel is also really dumb unless you spend tons of time and effort making it smarter, in that when you say, okay, this element here on the left maps to this element here on the right, Excel has no idea whether the element on the left exists or is spelled right, and whether the element or the path on the right exists or is spelled right, or is in fact navigable along the path that you've specified. Isn't smart enough to know that, hey, this thing over here is a date and this thing over here is a string. Is that cool with you? Or more fun, this thing over here is a code and this thing over here is a number. And by the way, the codes are not numeric, and that's probably not going to work so well. And so having something better is helpful. Profile mappings are sort of our lowest level of sophistication. It's not significantly better than Excel. The main benefit of profile level mappings is that when you publish an implementation guide, the mappings will show up in that implementation guide as opposed to sitting somewhere else in a spreadsheet. So you can actually be looking at a profile that says, here's the different data elements that we expect you to populate, and click on another tab and see, oh, and here's how this maps to HL7 version 2 or to CDA or to our internal database, because you've got a profile is specific to your organization. This mapping structure, you predefine what are the kinds of maps that you can have, and then you have text that says, how are you mapping? It is possible to specify a formal mapping language, but by and large, most people just use hand-wavy text. And they can embed comments, they can put stuff in brackets, they can say, it maps to this most of the time, but sometimes it maps to that, and you may need to truncate, whatever your logic is. So the same kind of stuff that you would cram into an Excel spreadsheet row, but at least now it's stored in a FHIR resource, so it can be transmitted in the same ways that you would transmit the resource. It will render as part of your publication tooling. And at minimum, you know that the left-hand side column really exists because you're embedded in the profile that is defining that left-hand side column. Second category, and I forgot to change the title on this slide, is concept map. Might be a little bit small to read. This is for mapping terminologies. And it's a little bit smarter than your typical Excel spreadsheet because it allows you to define groups. It allows you to say, hey, this thing maps, but it's broader than. So my left-hand side says aquamarine, and my right-hand side says blue. And in fact, when it comes to aquamarine, I'm going to put in two mappings. I'm going to say, well, aquamarine kind of maps to blue, and it kind of maps to green. And I can express that notion of kinda in that it is both smaller than and broader than what I'm mapping to in a computable fashion. And so that you can understand when you're transforming data that, well, I can transform here, but I've actually got two different choices and both of them are kind of wishy-washy, and set rules around what do you do in that circumstance, and have some sense of when are you losing data and when are you not. You can also have mappings that are conditional. So it might be that this element maps to one SNOMED code if the body site is arm. It maps to a different SNOMED code if the body site is leg, because there's actually multiple data elements in the source model, whereas in the target model, you've got a single code that's pre-coordinates or post-coordinates all of those things, and it can handle that as well. And of course, when you put that stuff into computable form, you can then spit that out in a nice little table in your implementation guide, but you can also hit a terminology service and say, hey, I've got this ICD-10 code. I would like it ever so much if you could give me the closest equivalent SNOMED code, and it will come back and give you that code, provided that one exists. And so that's definitely something that you cannot do with Excel. And of course, you've got all the benefits of source control and stuff like that, which Excel you can do, but it doesn't work super well. Finally, we have structure map. And structure map does something similar to what concept map does. Concept map is about mapping terminologies. Structure map, oddly enough, is about mapping structures. And it is not specific to FHIR. it is of course a FHIR resource, but you can use structure map to convert between a CSV file and a JSON data structure, or between version 2 and X12, or between a V3 and Canadian specification in Alberta and the equivalent V3 and Canadian specification in Ontario. So it doesn't really care what the data model is, so long as it can be expressed in hierarchical terms of, I've got a collection of data elements that might contain other data elements, and they all have types, etc. And structure map is a resource, but behind it, there's actually a computable language, and most people who write structure maps write it in the language form and then compile it into the structure map XML or JSON. But it lets you do all kinds of weird, wild things. So you can create libraries of these things. You can create reusable transforms that convert certain data types or certain reusable data structures. You can have default rules. You can do a base transform and then supplement it with an additional transform. Super, super powerful. It's much more powerful than even something like XSLT. Probably not quite as powerful as JavaScript, because you can do anything in JavaScript, but JavaScript is also not purpose built for this. One of the really powerful things that you can do with a structure map is not only can you run it on instances, but you can run it on the models themselves. So you can actually say, this is what happens when you transform this model into this other model, and it knows how to check itself, which is not something that you can do with most other transformation tools. And if you recall, structure map was one of the options that we had with questionnaires in terms of both doing population and doing extraction. And we have this, we are using this in some of our implementation guides in FHIR to say, hey, we have a social determinant of health questionnaire that represents a standardized instrument, and you can fill in a questionnaire response. But once that questionnaire response is complete, you can execute this particular structure map, and it will generate observations that we can automatically put into the record. And it will also, based on the score, generate a draft non-confirmed health condition that says, based on these answers, it looks like this person may have food insecurity. And that then can go into the EHR as, do you want to confirm this or not? Do you want to put this in the chart? And that gives us a lot more consistency about how information is exposed in the EHR and how it's searchable and retrievable. So that is all I wanted to say, or all that I had prepared to say on these topics. If you are interested in doing further exploration on structured data capture, the link to the implementation guide is there. You can, I believe I heard the tail end of Sheridan pumping chat.fhir.org as a resource to come and ask questions. There is a channel specifically on questionnaires, and there is another channel specifically on mapping that if you have particular interest in either of those spaces, you can go search and see if your question's already been asked and answered. But if not, you can certainly reach out to the community and ask your question. And we're pretty friendly. We receive questions all the time. I spend a good portion of my time as a community manager, and probably average 1 to 2 hours a day answering questions from different folks about all kinds of topics. And there's lots of other people who do that as well. And so we certainly welcome and encourage people to ask. But as you get more involved in the community, we also encourage you to answer. If you have an opinion, or you know something, or you have read something, or you have, from the school of hard knocks, discovered, yes, I understand why that blows up. You have to do X to make it work. the rest of the world is happier when you share that knowledge. So I'm going to stop here. And do you have questions?